Today we are going to chat inverse functions. Options galore. As you can see at the top of the screen, there is a bookwork of which I will have a worksheet over available if you want to go this route. Notice this is very short. This is like 7-8 problems in your set. Or your other option will be the inverse functions practice. There's more to it, but there's also some different types of questions. So there's benefits to both. You can do one or the other though, and I'll have keys for both. So inverses, what are they? How do we do them? Okay. Our biggest things, and we're going to kind of do them part by part here. So I'm going to do a quick reference to what these things mean, and then we'll actually do them down below. So to find the inverse, you must switch the x and the y. Now sometimes that'll be as simple as if I give you a chart or I give you some coordinate points, it literally just means the y's become your x's, and the x's become your y's. Okay? It can be that simple at times. And that would be true if these were coordinate points as well. And let me kind of explain that for a second. If I were to write this first xy pair as a coordinate point, the inverse of that point, if I were graphing it, just is basically taking those two values and switching them. The -2 became my y, the 4 became my x. And they would make this reflection, which we're going to talk about when we get to some of the graphing ones here momentarily. So that's one of the things that I can look at. Okay. Another way with switching the x and y for our first one can be if I'm given an equation. So if I'm given an equation, first job is we're going to switch the x and y. And once I do that, okay, so we're going to, actually, I should have put this little note in here, but I will put it right here. So first we switch x and y. And then solve for y. And that'll be true anytime you're asked to find an inverse. So it's not just switch the x and y here and I'm done. I actually got to figure out what y equals. So just like we would any other time, my job's to isolate my y term first. So I do my opposite of my -4. Be careful. This on the left is x plus 4, not 4x. Okay, they're not like terms. And then to finish it up, of course, we would divide by 2. Now, here's another suggestion that I have. Okay, if I was just looking for the equation, I absolutely could just circle this, written like that, and call it good. But what we're going to find out here in a little bit is we're going to be graphing these a lot of the time. So graphing it in that form is a little bit tricky. So what I suggest is taking each individual part and dividing by 2. So 1 over 2 is 1/2. 4 divided by 2 is 2. And that way it's more into a slope-intercept form where I can graph it a little bit easier. Okay, or at least punch it in my calculator's graphing function to make it a little bit easier. But we'll chat about that when we get to the graphing. So as I move through these, I just keep reminding myself, switch x and y, and then we're solving for y. Keep isolating that y term before you do anything else. Some of you here look at the fraction and go, ooh, I want to get rid of it, which is a good idea, just not the first step. Now at this point, some of you would decide you were just going to get rid of the fraction at this point. Some of you are going to deal with the fraction and just multiply by the reciprocal. Now to me, for a lot of you, I would suggest doing this in 2 pieces. Thank you. For a lot of you, bless you, I would go ahead and just multiply by 3 at the start. Okay, that gets rid of my fraction on the left. And I distribute the 3 on the right. jumbo size a little bit more here for just a second. So for those of you writing, you're not going blind. Just wait for me to make it a little bigger. And then divide by -2. And again, I can do that all at once if I wanted to multiply by the reciprocal. 18 divided by 2 is 9. Or I can do it in individual pieces like that. But I keep working until I get y alone. That's going to be my big thing. Will there be some twists? Of course there will be some twists. There always is. So when I look at this, I go, okay, switch x and y. That has not changed. Isolate my y term, even if it has a squared on it. So I get the 8 out of there. Again, minusing it, not like terms. Still working on getting my y term isolated. So my next job is to get the 2 out of there. Again, I'll even divide them each individually to try and keep that going a little bit easier this way. Again, there's a coefficient in front of my x. 8 divided by 2 is 4. Again, just take your time as you do that so we don't make some of the silly mistakes. But I don't quite have y solved for yet, because I still have a squared on there. So how do I undo squared? What's the opposite of squaring something? Square root. And the only other thing that I would keep in mind on this is, since it's a squared, that I try to remember that it's going to be plus minus. Okay, if that's the one little thing I forget, it's not the worst thing ever. It's just, doesn't have me completely up to speed otherwise. But really, this is more like Algebra 1 type stuff, where we're attempting to get an equation solved for. Okay, one more. So I want to make sure we cover every option here. So here, again, trying to get y by itself. I know we're not big fans of fractions, but sometimes it doesn't hurt to deal with them. We'll get it out of here soon enough. We may have to steal a little bit of room up here in a second. We'll see. So here again, you could multiply by the reciprocal. You could multiply by 5/2. Or you can do it in 2 steps to feel a little more comfortable. So on the right, the 5s would cancel. Over here, we'd have 5x. 5 times 4 is 20. Divided by 5 is 4. And we would divide everything by 2. If it doesn't go in nice, that's okay. 4 divided by 2 is 2. And I'd get my inverse. So as you can see, our answers aren't always going to look nice, neat, and tidy. A lot of times there's going to be fractions and stuff involved, but if we take our time and go step by step, it shouldn't be too bad of a process. Issues on how that works on any of these so far. So then we finally are going to get to the next part. Now, down here it says the inverse is a function if the original passes the horizontal line test. Again, horizontal is side to side. Okay, we did the vertical line test before. We were trying to figure out if our function, if it was a function. Now we're testing for the inverse. So basically all we're going to do is we're going to take and draw a horizontal line somewhere towards the middle of our graph. And we're going to look to see how many times it crosses our graph. If it only crosses at one point and one point alone, then yes, the inverse would also be a function. But if I put that that horizontal line through, and it goes through multiple points, I mean multiple points. Hello. It really doesn't matter how many more than one, just that there's more than one point it's crossing. Okay, that inverse will not be a function. It's not going to pass the vertical line test if we did that. So I just got to keep telling myself it's the horizontal line test that I'm using here. And if I can keep that straight, I'm in good shape. Okay. Issues. Okay. So as we flip over, I'm just looking at one thing as we go. Okay. More inverse practice. We're going to look at 11 and 12 on the back because 9 and 10 are kind of like the ones we've been doing. But I also want to make mention and give a reminder. F of x is just a fancy way of saying y equals. So if you want to just put in the y right away, that's okay. So then to find the inverse, what do? I switch x and y. And this is where this one gets a little funky. Okay, I switched x and y. Well, wait a minute. The y is in the denominator. Well, normally I multiply by what's in the denominator. I still do. So we're going to multiply, in this particular case, both sides by y. It's going to look weird, but that's okay. But now at least y is out of the denominator. And since I'm solving for y, and right now I'm multiplying it by x, we're going to divide by x. And we're going to get to our answer. So again, just follow the rules you know, even if it seems a little strange. And the same thing's going to happen here on 12. I switch x and y. Now my goal is to get to y, but I have a problem. Y is in radical jail. Well, cubed radical jail. It's like higher, I guess that's worse jail. I don't know. But the opposite of taking the cubed root of something is to cube it. Just like if it were the square root, we'd square it. Because the cubed and the cube root are inverses. And again, my goal is to get y alone, so I only got one step left. And that's to plus the 8. And we're set. So we're just kind of taking a peek at this as we go. So now we get into some problems. You're like, oh boy, there's lots of words coming. Does this mean I got to do explanations? Little ones, okay? Find the inverse of the function f of x equals x squared. X is greater than or equal to 0. Okay, that's not part of what I'm solving. This is what I'm solving. Remember, that's my y equals. So find the inverse. Okay. X equals y squared. And now I take the square root, because that's the inverse of squared. So now, here's the part that we may not think about very often, but I'm going to have you think about for a minute. So, why does this only work when x is greater than or equal to 0? Now, if I don't think about mathematically why that is, which we'll talk about once we see a picture here, you also always have the option, which is the nice thing about the graphing calculator, of taking a look at this and seeing why it doesn't work. So if I go to y equals, and I do the square root of x, and I graph it, I notice something. My graph never goes into the negative values of x. And I see that on my chart too. Okay, once we hit 0, I get error, 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 error. Well, why? Because I can't take the square root of a negative. Now, some of you are going to say, well, yes, we can. We just got to pull an I out. Ooh, nicely played. But if it's not something I can graph, I can't graph I. So that's why this happens. But my main reason of doing this is if you see this show up on a problem, you're not solving for that. Okay, this is the problem I'm working on. That's just a label telling me a restriction. And the rest of this is just kind of some review of the things we did on the front, even though we're going to be doing a couple of other pieces on the worksheet as the rest of our lesson here. So we're going to go past 14, 15. Explain how to use the horizontal line test to determine if an inverse relation is an inverse function. Okay. If the horizontal line only goes through one point, it's an inverse. If the horizontal line goes through 2 plus points, it's not. And we saw the visual of that on the front, but being able to explain it in words is something that can be helpful as well. And then this last part's going to intro us straight into what we're going to do for some practice problems on the worksheet here to make life easier on us. So finally, describe how the graph of a relation and the graph of the inverse are related. Okay. The points are inverses, or I'll even take the word flipped if you want more of a non-mathematical lingo type thing. And like we'd mentioned on the front, because we're going to put an example in here to kind of see what are we talking about. So let's say I had 3 points that I'd graphed, and I wanted to see what the inverse was. The inverse, again, would just be flipping the x and y values. And we'll see when we do them on the graph, we're reflecting them over this line called y equals x, which is just a diagonal line. But we get to see the reflection that way. And then finally, explain the steps in finding the equation of an inverse. We talked about it on the front, but we'll do it one more time to reinforce it. We're going to switch x and y. We're going to solve for y. And since I'm pretty sure that with your assignment options being between a worksheet and bookwork, that like 98.3% of you are going to go with a worksheet over bookwork. What I'm going to do is I'm going to jump in on the worksheet and go over a few problems with you just to kind of reinforce a couple things we did and to get some of the homework started, which is always a good idea. So let me move this to the side. Move this down a little bit. Okay. I'm not going to knock out some of the easy ones for you here. What I want to do is go through some of the stuff where I think you might have not quite as good as an example on your notes. So, find the inverse. I'm just switching x and y's. Okay, you can do that. Use the horizontal line test to determine if it's a function. Does it go through once? Does it go through more than once? Okay. Then we get down to 6 through 8. And we get something a little different. It says match the graph with the graph of its inverse. So 6, 7, and 8, their graphs, their inverses are somewhere in A, B, and C. So what we're going to attempt to do here is figure this out. You're like, well, how do I figure it out? Well, what I would do is I would find some points that I could easily label. Okay, and it doesn't matter where they are. If you find any random points here, just pick a few. You don't have to do them all. But just write down a few coordinates. So what I'm going to do then is I'm going to go looking for another graph that would have inverses of those points. Now, 6 is a little bit easier because when you're looking at the other graphs, you only see one straight line. But let's say we started looking. We said, okay, so this is, for instance, at -5, -2. Notice they're inverses of each other. Or if I come here, I have one at 0, 3, where over here it was at 3, 0. If I can find a couple of points that are inverses, that tells me where the graph of that inverse is. So I pick a few points, I pick a few on the other ones, and I start to look and see, hey, where are those flipped point graphs going to be? And that's how I solve them. So let's do one that's not quite so obvious. Let's do 7. So again, take some points. There's 1. Okay, even if it's just a couple. And then maybe what I do is I go, all right, let's see here. Looks similar. C kind of looks close. Let's try this. So I try here and I go, okay, so this is at 1, 0. Then I'm like, well, wait a minute. 1, 0 and -1, 0, those aren't inverses. Let's try one more point. Let's see. Here. 3, 4. Okay, yeah, I don't think it's this one. So let's try over here. So that's at 0, -1. Yep, switched X and Y. This is at 2, 3. Yep, switched X and Y. Oh, okay. And I can start thinking about it that way. So you can actually see how this inverse thing is going to work a little bit. So you're like, okay, this maybe. So then we get to the part that we haven't talked about yet. Verify that f and g are inverse functions. Okay, here's how this is going to work. We've got to prove that f of g of x, so like, oh crap, compositions are back, and g of f of x, that both of them equal plain old x. If they equal anything else, they equal 3x, x plus 7, it doesn't matter, they're not inverses. So here's how this works. So let's say, for instance, we do number 9. Okay, so if I'm going to do f of g of x, what that means is I'm going to take my g of x, I'm going to plug it into f. In other words, g of x is x minus 5. So I'm going to take this x minus 5, and I'm going to plug it in for that x. So replace the x with x minus 5. But then the plus 5 from my f function is still there. So I take a peek, and I go, okay, so x, -5 plus 5 cancels. Okay, so the first one equaled x. That's a good thing. And then if the first one works, I try out the second one. But now I'm going to plug f into g. Okay, it's going to work the other way around. So here's my g function. I'm going to plug x plus 5 in for x. Okay, whatever's in the parentheses goes in where the x goes. Again, +5 and -5 cancel. And I just showed they're inverses. Okay, both my compositions, f of g of x and g of f of x, both equaled x. And so I'm okay. Now, if they wouldn't both equal x, then they're not inverses. And that's kind of what we're trying to prove. So as we look at some more of these, let me flip this over. Oh yeah, I want to do one more of these with you. Oh, that looks fun and complex. Let's do 11. f of g of x, okay, means we're doing f of the fifth root of x. Oh dear. Okay, here's my f function. So I'm going to replace the x with the fifth root of x, but then the exponent is still there. And what we know from before is, like if we have a square root and a squared, they cancel. They're inverses. If I have a cubed root and a cube, they're opposites. They cancel. Here, I have a fifth root and a 5. They cancel. And just leave me with the x. I'm good. Now I just got to make sure it works both directions. And sometimes it may work in one direction and not the other. Bless you. So here, I'm going to take my g function, and I'm going to replace the x with x to the fifth, and I'm in the same situation. Okay? Fifth root and fifth power are inverses, and just leave me with what's underneath. And I'm good. So when you're asked to prove it, that's how you prove it. If you're asked to verify it, that's how you verify it. We make that work. And so then the last thing we're going to do, because again, define an equation is the switch x and y, solve for y part. Oops, let me switch that over. So once we switch x and y, we're going to get y by itself, and we're going to be done. When we get down to 19, 20, and 21, it says sketch the inverse of f on the coordinate system. That's going to seem interesting. Some of you that are watching this later are going, what's he talking about? Oh, down here. Okay. So here's how this is going to work. This is the line y equals x. This is the line we're reflecting over. So if I were to take my paper when we get done and fold it over that dotted line, I'd see the same points on each side. So how am I going to sketch the inverse? Well, we're going to find some points on here. And I'm just going to jot them down here at the bottom instead of writing them all up there. So this, for instance, is 4, -4. And 3, -2. 2, 0. Let's do one more. 0, 4. Okay. I just want to get several points that I can see on the line that they give me already. And so my job now is going to be to take those coordinate points, find their inverses, or flip the x and y around, and plot those points, because they're going to form my new line. So if I go to -4, 4, -2, 3, and 0, 2, and 4, 0, and connect the dots, I start to see some of the reflection. These 2 points are equally far away from y equals x. And so are these 2. And so are these 2. And so are these 2. And that's the whole idea of this reflection, or sketching the inverse. Okay? I just draw the picture, and I'm set. And we can even get to a point that we can do that if we're given 2 equations. And we'll do a little bit of that tomorrow. So your job would be to kind of play with some of the rest of these, see how they're going. If there's some trouble spots, which there could be, ask some questions, check out the key, try a few here in this last 15 minutes or so, and then we'll hit them up again tomorrow.